Okay, I ended the last video somewhat abruptly. So what I'm going to do here is I'm going to find the interval of convergence for this series using the ratio test. And the two steps are similar to what we did with the root test. I'm going to solve ratio limit less than 1, and that's where I have absolute convergence. And then I'm going to solve ratio limit equals 1, and I have to hand test. So I'll start out with this part right here. So this is the first part. So I set up my ratio limit. Now, this is equal to, this is a k plus 1 minus 1 k plus 1, k plus 1, x to the k plus 1 over 2 to the k plus 1. And then this is ak on the bottom. I get absolute values. So this means that I need to solve this limit less than 1. But let's clean this up. That's going to be 1, so I can get rid of that. I don't need absolute values for k because k is positive. Same with the 2, but x could be negative. So what I'm going to end up with is this is going to be k plus 1, absolute x, k plus 1, over 2k plus 1 over k, absolute x to the k, over 2k. I'm going to solve this less than 1, but let's set it up. So I get k plus 1. I'm going to bring this up here. And feel free to use shortcuts here. Over 2 to the k plus 1. I invert and multiply. Okay, so I get that. And I can get some cancellation here, but I like to rewrite things. So we get like terms over like terms. And I get limit this one over this. And this one over this. Okay. Now I'm going to continue on the next page, so I'll slide this up. Let's see, a little bit, so you can see what I've done before. So this is going to be limit 1 plus 1 over k, x plus k, that's going to be minus k here, so those cancel. So I just get absolute x, and here I'm going to get over 2. Now I need to solve that less than 1. Again, I take this limit here. That's 1 plus 0. There's no k here, so I get an x here, and I get a 2, and I want that less than 1. So that's what I need to solve. The ratio limit less than 1. Oops. Let's bring that down a little bit. I need to solve the ratio limit less than 1. That's what I'm doing now. And so that's what I'm started up here, and I get here. So that tells me that absolute x is less than 2, or minus 2 and 2 in the interval of convergence is at least minus 2 to 2, and I need to test x equal minus 2, x equal 2, and I'll do that on the next page. So again, I just did step 1, now I have to do step 2. So I'll put that in parentheses. Okay. So now I say, okay, well, rho equals 1, that's x over 2, less than that, and that's going to be absolute x equals 2, so x equals minus 2 and 2. That's what I meant there. I knew I was going to have to do that in advance. So you can abbreviate it. So when x is equal to minus 2, let's plug it into the series. K is equal to 1, infinity, minus 1 to the k. K, plug in, I'm sorry, you can't see that. Here's the original series. And so I get minus 2 to the k, and it's all over 2 to the k. Okay. That's where I got that. So simplify, this is going to be minus 1 to the k. I get a k here. And then what I'm going to get is minus 2 to the k over 2. Well, that's going to be minus 1. So I get k is equal to 1 minus 1 to the k. I get this k here, and I'm going to get minus 2 over 2 to the k. These are going to cancel, and so I'm just going to get this. Okay. So I know that this is divergence here. That series diverges. So when I plug in 2, I'll do this a little quicker so you can see I get minus 1 to the k, 2 to the k, over 2 to the k. That's going to cancel. So let's write out a few terms. I get negative 1. When k is equal to 2, I'm going to get positive plus 2. When k is equal to 3, I'm going to get 3. When k is equal to 4, I'm going to get plus 4. And what's going to happen here? Minus 1 minus 3 is minus 4. Then I get 0. Then I'm going to get a minus 5 plus 6. I'm going to get a 1. So what's going to happen is this series is going to jump all over the place. So Sn, this limit Sn, does not exist. And so the series diverges. I mean, that should make sense. We're going to get from really large positive numbers to really large negative numbers. So this limit's not going to exist. But this series diverges. So we get here we get divergence. So the interval of convergence equals, well, it was at least minus 2 to 2. We tested the endpoints, diverged here and here. So the interval of convergence is minus 2 to 2, and the radius of convergence is equal to the length of the interval divided by 2, which is 2. 4 divided by 2 is 2. That's the radius of convergence. That's the interval of convergence.